The first x is x squared. The second x is x to the 1. So you pick x to the 1 because 1 is smaller than 2. Look, do both terms have a y? Yeah, so y will be part of your greatest common factor. Both exponents on the y's are 1. So you're going to factor out a y to the 1. If the exponents are the same, then that's the y and that's the exponent that you factor out. Do both terms have a z? Yes, which z has the smallest exponent? Z squared. So z squared will be part of your GCF. 2xyz squared is your GCF for that problem. Okay? Factoring is really dividing. Factoring is really dividing. So you're dividing out a 2xyz to the second from both of your original terms. So you say 20 divided by 2 is 10. X squared divided by x is x. Y divided by y cancels. Z to the third divided by z squared is z. Factoring is dividing. So you're dividing out 20x squared y cubed by 2xy squared, z squared. Go to the next term. Negative 18 divided by 2 is negative 9. X divided by x cancels. Y divided by y. And z squared divided by z squared cancels. So you just have a minus 9. Okay? GCF is fairly simple to check. You just check by distributing your GCF in your head, not on your paper. You can if you want to. You don't have to show your checks, but this is what you'll do mentally. Does the outside term multiplied times my parentheses give me what I started with? Okay, that's what factoring is. What are some factors of 12? Just making this off the top of my head. What are some factors of 12? Okay, give me 2 factors of 12. Let's just work with 2. 2 and 6. 2 and 6 are factors of 12 because they multiply to be 12. 2 and 6 are factors of 12 because 2 times 6 is 12. 2xyz squared and 10xz minus 9 are factors of our original problem because they multiply back together to get what you started with. Okay, it's just much more complicated when you start to throw in variables and exponents and all that kind of good stuff. Okay, GCF, and we'll look at some problems together. We're just going to go over the 4 different types of factoring. All right, if you have a binomial, there are 3 different binomials that we're going to know how to factor. Okay, the first one is called the difference of squares. The first one is the difference of squares. 25x squared is a perfect square, and 16y squared is a perfect square. Okay, and they're separated by a minus sign, so that's called the difference of 2 perfect squares. The difference of 2 perfect squares always factors into 2 binomials. They're going to be exactly the same, except one's going to have a positive and the other one's going to have a negative. We've seen those before. Those are called conjugates. Okay? The next binomial that we're going to look at is the difference of cubes. It is new. If you're thinking, I have never, ever seen that, I did not learn that in Algebra 1, you are correct. That is an Algebra 2 type of factoring, but it's still a binomial. And the sum of cubes is also new. Now, right away, I want you to understand the sum and the difference of cubes. The way that we factor those is by using a formula. So I want you to write formula. And I want you to write memorize. Factoring the sum and the difference of cubes is a formula. It's not something that you're just going to know how to do. You're just going to have to memorize the formula. So let's talk about cubes. You have a purple sheet. Is it purple? You have a purple sheet. You have an x cubed on that purple sheet, and every number underneath that x cube is a perfect cube. I have a few of them memorized. 2 cubed is what? 8. So 8's a perfect cube. 3 cubed is 27. So 27 is a perfect cube. 4 cubed, y'all happen to have that memorized? 64. Is 64. So 64 is a perfect cube. 5 cubed is 125. Okay, you can still use your purple sheet if you don't have those memorized. Those are numbers that are perfect cubes. Let's talk about variables for just a second. If a variable is a perfect cube, you have to think differently. If a variable is a perfect cube, its exponent is divisible by 3. Okay? So I'm going to write down some variables that are perfect cubes. A to the third is a perfect cube because 3 is divisible by 3. Okay? A to the sixth is a perfect cube because 6 is divisible by 3. You have to think totally different when you're looking at your variables. So what's the next perfect cube? A to the ninth is a perfect cube because 9 is divisible by 3. A to the 12th is a perfect cube because 12 is divisible by 3. Remember, when you take the cube root of a variable, you have to divide the index into the exponent. So variables are going to be perfect cubes if their exponent is divisible by 3. If their exponent's not divisible by 3, they're not a perfect cube. Okay? Same thing with perfect squares. What's an exponent have to be divisible by to be a perfect square? 2. Because 2 is the index. Okay? So you have to think a little bit differently when you're factoring the difference in the sum of cubes. So the first example that I gave you is 8a to the third minus b to the third. So you look at 8 and you say, hey, that's a perfect cube. A to the third is a perfect cube because 3 is divisible by 3. B to the third is a perfect cube because its exponent is divisible by 3. And then we use our formula. And I've got this written down, but I'm just going to work it out so you can see me work it out. So factoring the difference of cubes, I always get a binomial times a trinomial. It is a formula. Okay? You take the cube root of the first term. So 8a to the third. You asked yourself, what times itself 3 times is 8a to the third? 2a. Okay? That's how you get the first term in your binomial. You take the sign, and the sign between your two terms is minus. You bring the sign down. So you bring down a minus. You take the cube root of b to the third. What times itself 3 times is b to the third, or what's the cube root of b to the third? That's saying the same thing. b. All right, that's how you get your binomial. You take the cube root of 8a cubed, which is 2a. Bring down your sign, which is minus. You take the cube root of b to the third, which is b. Then the formula says you take your first term of your binomial and you square it. So 2a is the first term of my binomial. I square 2a and I get 4a squared. The formula says change the sign. So whatever sign you have in your binomial, you're fixing to change that sign. So minus turns into a plus. To get the middle term, we're going to multiply the two terms together. 2a times b. Don't double here. This is not square double square. 2a times b is 2ab. That's how you get the middle term. And then you square the last term. b times b is b squared. That's called the factoring the difference of cubes. We'll look at some examples in a minute. You don't solve it. You're just factoring. If you were solving, there would have to be an equal in the an equal sign in the problem. So we're not solving, we're just factoring. Okay, let's look at the sum of cubes. The sum of cubes is the same exact formula. The sum of cubes is the same exact formula, and I've got it worked out, but I just want you to see me work it out. So x to the third is a perfect cube because its exponent is divisible by 3. Y to the 6 is a perfect cube because its exponent is divisible by 3. We're doing a little formula here. We're going to do a binomial times a trinomial. And again, the answer's there. I want to walk through the problem with you. What cubed gives you x cubed? Or what's the cube root of x cubed? X. Bring down the sign. This time the sign is plus. What is the cube root of y to the 6th? Y squared. Okay, that's how you get your binomial. You take the first term in your binomial and you square it. So x squared is x squared. You take the sign that's in your binomial and change it. So that middle sign is going to be minus if the sign in the binomial is plus. You multiply the two terms together. X times y squared is just xy squared. You don't double here. That's something totally different. That's a binomial squared. And then you square the last term. Y squared is y to the fourth. And then you're done. It's a binomial times a trinomial. It is new. It's something that you're going to have to memorize. It's a formula. We'll practice that a little bit more in just a minute. Any quick questions? All right, let's look at trinomials. If you have a trinomial, this is something that you learned in Algebra 1. If you learn some tricks like bottoms up and tic-tac-toe to factor your trinomials, we're going to throw those tricks out the window because we've got to be able to factor things quickly. We don't need a little trick to factor, okay? We need two things that multiply back together to get what we started with. So if your trinomial, okay, has a last sign that is positive. So my first two examples is showing you what you do with your trinomial. It needs to be in standard form with the highest exponent first. If the last term is positive, that means your signs are the same. If your last term is positive, that means your signs are the same. Because the only way to multiply two things together to get something that's positive is if both of the things are positive or both of the things are negative. Okay, so if you need to write that down, if C is positive, the signs are the same. If C is positive, the signs are the same. And those signs will be whatever the middle sign is in your trinomial. If your C or your last term is positive, your signs are the same, and your signs will be whatever the middle sign is in your trinomial. If C is negative, then your signs are different or opposites, however you want to say that. If your last term, we're going to call that C. If your last term is negative, it means your signs are different. It might be plus and a minus, or it could be a minus and a plus. Doesn't matter, but the signs inside your two binomials are going to be different signs. All right, the next two examples are just showing you that if you end up with something like x plus 5 times x plus 5, the book is probably going to write that as x plus 5 binomial squared. Okay? It's okay to write x plus 5 times x plus 5 as your factors, but the book will probably go ahead and write it as x plus 5 squared just because that's a simpler way to write it. All right, last way to factor that we're going to look at is grouping, and then we want to actually look at some problems. So when I look at that first example under grouping, the clue here that it's grouping is that I have two groups that are exactly the same. I have two groups already in my problem that are exactly the same. I have a y minus 3, and I have another group that has exactly the same thing, y minus 3. So you can actually factor out the y minus 3. It's kind of like a GCF. It really is a GCF. But some textbooks put this one into the grouping category. So if I have 5x times y minus 3 plus 2 times y minus 3, and I factor out a y minus 3, then I'm left with 5x plus 2. You're actually dividing it out. Factoring is dividing. You're actually factoring out that common group because it's being multiplied times the 5x and the 2. When you do that, you're left with the 5x plus 2. So y minus 3 and 5x plus 2 are considered your factors. If you have how many terms in the second example? If you have 4 terms, then 4 terms is a clue that you are grouping. You usually group the first 2 terms together with the last 2 terms. So take a look at those first 2 terms. What's the greatest common factor between R, S, and 5R? R. So we're going to factor out an R. We're left with S plus 5. In the parentheses that has ST plus 5T, what's the GCF between ST and 5T? T. We're going to factor out a T. And when we do that, we have created a common group. Both of those terms have an S plus 5. So you can factor out the S plus 5. And then you'll just mark out those little S plus 5s because you're factoring it out. And you'll be left with R plus T. Factoring by grouping. Probably one of the easier ways to factor once you get in the groove of this. Okay?